Previously, I talked about the subject of learning. And learning, if you remember, we defined as a relatively permanent change in behavior as a result of experience. And it's the relative permanence of learning, or the relative permanence in the change in behavior that brings us into the discussion of memory and what memory is. Uh, Albert Einstein is quoted as having said, "Memory is deceptive because it's colored by today's events." And what did he mean by that? Well, he was getting at the fact that the things that we remember that have occurred in the past are influenced by the current state of mind that we're in right now. So, our current expectations of how the world works often influence the way that we remember events that have occurred in the past. So, first of all, we need to start off by defining what do we mean by memory? Well, memory is an internal record or representation of some event or experience. It's obviously rooted in the brain. We don't have an exact understanding of this, but it's some sort of recording, some sort of representation. Representation is probably a better way to phrase it, within our brains that is a result of some previous experience. Because there is a representation there, many times we have the ability to access those memories and become aware of them. Sometimes we don't have that ability, though, and that's one of the things that we're going to be talking about today as well, as the different kinds of memories. It's also a constructive process, as I just said. It can be influenced by, our memory of things that have happened in the past can be very easily influenced by the state that we're in the present. So it's a constructive process in that we're organizing and shaping information during the processing as well as during storage and retrieval of memories. And those are really the three basic aspects that most researchers refer to when they talk about memory. But one thing that it's important to remember is that memory is not a videotape of the experience. Memory is constructed. In other words, memory is not perfect. Okay, so as I mentioned, encoding, storage, and retrieval are the three primary stages through which memory gets processed through. So encoding really refers to when we process information into memory. This is a model that is analogous to the way that computers process information. Okay, so the way that information gets into a computer is by typing on a keyboard, and that typing on the keyboard gets encoded in a way that the computer can understand and use. Usually, information is coded as a series of zeros and ones, and in our brains, it's coded in a neural impulse, a network of connections among neurons. Storage, then, is when we store the information to retain it over time, sort of like pressing the save button in your Word document. Okay, that's what actually gets it saved onto the hard drive. You could type something in there, but if you X out of the window and it doesn't have a chance to get saved first, then that information is lost. So similarly, although you could encode something, you may not store it properly, in which case it's not going to be in there in terms of memory. And finally, the third stage is retrieval. So hopefully later we can recover that information from memory, similar to how we might try to open a file on our computer and bring it to the screen for viewing. Although sometimes we forget where we stored a file. Sometimes we can use the search function to help us locate that. That's analogous to when somebody might provide us a cue and say, "Hey, do you remember when this happened?" And sometimes we remember. Other times, you type something into the search box and nothing comes up. And, it could be because the file was deleted. It could be because you didn't actually name it what you thought you named it, and so that's why it's not coming up. That would be analogous to somebody saying, "Hey, don't you remember when this happened?" And you say, "No, actually, I don't remember when that happened." So retrieval is a critical step in memory because it allows us to get access to it once it has been successfully stored in there. And so, That's one of the major models of how memory works. Another model that is involves some similarities is called the three-stage model, where stimulus from the environment gets encoded as a sensory memory first. Okay, so here we're going to introduce the idea that there are three distinct, or I should say at least three distinct types of memory. Okay, sensory memory is the briefest form of memory. The purpose of it is to hold sensory information very shortly. For visual information, this can last somewhere around a half a second, and for auditory information, this can last anywhere between 2 and 4 seconds. Now, once information gets encoded in or gets passed through sensory memory, it then has the opportunity to enter into short-term memory. And what determines whether it enters into short-term memory is whether we attend to it. That is, selectively attending to information in our environment in the form of various stimuli. That's what's actually going to get it into our short-term memory. If it doesn't get in there, the information will not be transferred, and it will essentially be lost. So the purpose of short-term memory is to hold information temporarily for analysis, and it's also involved in being utilized. Information gets utilized by short-term memory when we retrieve it from long-term memory. Now, the duration of short-term memory, in contrast to what the average person might say when you go up to them on the street and say, hey, how long do you think short-term memory lasts for? According to research, short-term memory lasts somewhere around up to 30 seconds. Whereas the capacity of sensory memory is extremely large, the capacity of short-term memory is relatively small. Okay, this is there's a very simple way that psychologists go about testing this. They present you with some bits of information, usually in the form of numbers, although they could be letters or they could be words. And what you tend to find is, just like a phone number, people tend to remember just about 7 digits, plus or minus 2. Some people can remember closer to 5, some people can remember closer to 9, but the average is 7. Information that is, once again, not transferred from short-term memory into long-term memory through encoding will be lost. Okay, so long-term memory storage is essentially then anything that lasts greater than 30 seconds. The purpose is that it receives and stores information from short-term memory for a potentially permanent amount of time. So if you are 25 years old, you might have memories from when you were 20 years old. Similarly, when you're 75 years old, you might have memories from when you were 5 years old as well. You might retain those memories for just about forever. The capacity, just like sensory memory, is very large. In fact, some might say that it's actually relatively unlimited, because there's no evidence to suggest that people can reach a finite amount of information getting stored in their long-term memory. And then, of course, again, short-term memory is going to become involved when we go to bring things out of long-term memory. It's almost good to think about short-term memory as what most people think about when they think of consciousness. Whatever you're thinking about at the present moment, that is essentially what is in your short-term memory. And that information can be kept there longer and longer through something called rehearsal, which is how, if we've ever had to look a phone number up and then dial it without being able to look at it at the same time, we probably had to rehearse that information. So as I said, sensory memory is a very short type of memory, and there are actually two types. There is something called iconic memory, which is a visual type of memory. And the best example of how to experience iconic memory would be to swing a flashlight in the dark, and what you'll see is that there's a bit of a trail behind that flashlight, and that's what your sensory memory is. Alternatively, if you've ever seen a lightning bolt flash on a dark night, it tends to remain there in your visual sensory memory for a brief period of time after the lightning has actually disappeared. Echoic memory, most people are also familiar with, even though they didn't know that it had that name or that it was really a form of memory per se. It's when somebody says something to you and you're not really paying attention to them, and you immediately say, "What did you say?" But before they even have a chance to respond, you can already remember what they said. And the reason why is because that information got stored there just long enough, again, just a couple of seconds really, for you to bring it into your short-term memory through the process of selective attention. So short-term memory, some people might say is very similar to another concept, or that it can also be known as working memory. Many psychologists would argue that there actually is a difference between simple short-term memory and working memory. Working memory is what you do with information that's in short-term memory. Short-term memory is just you could think of it as a storage area, whereas working memory is your capacity to actually do something with that information. So, in other words, short-term memory is almost like how many programs can you have running at the same time. Just windows open, in other words, whereas working memory would be how many of those windows can you have actively processing information on your computer at the same time. So as I said before, one way that we can keep information in our short-term memory for a longer period of time is through maintenance rehearsal. This is simply repeating the information over and over to get it to maintain it into short-term memory. Although you should be aware that that's not a great way to get it into long-term memory. That is, simply repeating information over and over again is not an effective strategy to get it into your long-term memory. What that means is that simply reading and rereading your notes or your textbook or reviewing lecture slides is not an effective way to get that information into your long-term memory. We'll talk about some of the things that can help you with that, but really it involves organizing that information and integrating it with things that you already know, making new associations between the new information that you're trying to learn with already known information. Another way that we can increase the capacity of short-term memory is to use a technique called chunking. This is when we just group separate pieces of information into a single unit or a chunk. So as I said before, although you can probably only remember roughly 7 bits of information at one time, you could extend that by grouping those numbers together. In fact, we typically do that when we tell people phone numbers. We say the first 3 numbers together, followed by the last 4 numbers together. And that's an example of chunking, because we can more easily remember those first 3 numbers as one bit of information, and then those next 4 numbers as a separate bit of information, and that can allow us to potentially expand the capacity that way. So long-term memory gets even a little bit more complex, just in terms of the number of different types of long-term memory there are. Long-term memory can be divided up very basically into explicit or declarative memory. Explicit and declarative mean essentially the same thing. This is memory in which you consciously recall information. Okay, the other type, in which you do not consciously recall the information, is called implicit or non-declarative memory. Okay, so this is a type of memory that does not involve conscious recollection. What do we mean by that? It doesn't involve conscious recollection. Well, as I'm talking to you right now, I'm making hand gestures. Even though there's nobody in front of me, I'm still making this similar hand gestures as I'm talking, just as if I would if I were in front of people. And why am I doing that? I'm not even paying attention to the fact that I'm doing it. Sure, I'm aware of the fact that I'm doing it now, but that's because it's an implicit memory. Specifically, it's a procedural memory. It's a memory for movements, skilled movements really, that occur without conscious knowledge of their occurrence. Okay, another example that we've already talked about is classical conditioning. That's also, if you recall, that also occurs at a relatively unconscious level. We don't have to be consciously aware of the associations in order for them to develop. And then a more complex, well, not necessarily more complex, but A third type of implicit memory, which most people will be less familiar with than the other two, is called priming. And it just refers to the fact that earlier exposure to a stimulus facilitates the subsequent processing of that stimulus. So the best example of this would be the first time that you see an unfamiliar word, you might have to sound out that word in order to say it correctly. But the more times you encounter that word, the more easily you can read that word. And that's what we're talking about with priming. The more times you're exposed to something, the more easily that information can be processed. So you essentially get faster and faster at reading certain words as a function of having been exposed to them before. And again, this works even if you don't remember being exposed to that information per se. Okay, so that takes care of the implicit or non-declarative memories. The explicit are probably the type that you tend to think of when you think of memories. There are two types. Once again, semantic memory, which is memory for facts and just general knowledge. For example, knowing that bananas are yellow, that there are 12 months in a year, the days of the week, that kind of thing. Okay? Episodic memory, on the other hand, is memory for personal experiences and events. So, for example, your high school graduation, the birth of your first child, even what you just ate for dinner, for breakfast or lunch, whatever the case may be, or even where you were when you were listening to the previous lecture on learning. Those are all examples of episodic memory. One helpful way to think about the distinction between the two is that semantic memories have essentially lost their context, the context in which that information was learned. For example, how do you know that bananas are yellow? Do you remember when you learned that information? Most likely not. How do you know that? Where were you, and when did you learn that there were 12 months in a year? You might say I was in elementary school, but you wouldn't know exactly when and where you were. But if I said when and where did you graduate high school, that is the type of information that you probably would know. Where you were and when it occurred. At least approximately, anyway. So once again, semantic memories have lost the context in which they were initially processed, whereas episodic memories have retained that information. Okay, so in terms of improving long-term memory, one thing that you can do is to use an organizational strategy, that is arranging a number of related items into categories that are further divided and subdivided. This makes material more understandable and more memorable. Those two go hand in hand, of course. Rehearsal, as I mentioned before, is not an effective strategy if you just use maintenance rehearsal. That's only good for keeping it in short-term memory. When I said giving something meaning, making meaning out of things, tying it in with things that you already know, that's what's referred to more as elaborative rehearsal. It's used for storage into long-term memory, and it's a process of linking new information to previously stored material. It's also called a deeper level of processing because it's not a superficial type of memory. It gets sort of deep down in there so that it makes it more likely to stick. Another thing you could do is to use mnemonic devices. These are learning tricks that help you retain information. For example, acronyms, outline organization, and also the method of loci. So the method of loci, what is that exactly? Well, that refers to remembering things based on creating mental images in familiar environments. So if you wanted to remember a list of things that you need to talk about in your lecture, you might picture different topics located in various places in your home. For instance, you might think about talking about episodic memory in your bedroom. So you walk in there and you say, okay, you visually walk yourself into your bedroom, and then you remember, okay, now I need to talk about episodic memory. Then you walk into the living room, and there your cue is to talk about semantic memory. And you could just walk through your home, and each location, each locus essentially, would be associated with a familiar place and That's how you would, those would essentially serve as retrieval cues for you to remember what it is that you're supposed to be doing when you go to those different locations. The key thing is that you're very familiar with the environment, and so you have no difficulty remembering where your bedroom is, where your living room, where your kitchen is, etc. Mnemonics, as I mentioned, or acronyms rather. Most people are familiar with the acronym HOLMES in order to remember the Great Lakes. So this is another way to, essentially have a retrieval cue at your exposure that can help you. In terms of using outline organization, most people will write outlines before they write essays. Okay, so you create an outline, and then you talk about specifically, or list specifically, what are you going to talk about when you are going to talk about memory models. Okay, you might say, okay, there's the information processing model where there are these three stages of encoding, storage, and retrieval. For sensory memory, you might give some examples. I'm going to talk about how during sensory memory you can sometimes recall what information somebody just exposed you to, but you immediately forgot. That's the example I gave before when somebody says, do you want to go to the park? And you immediately say, what? But then you recall that they just asked you if you wanted to go to the park, and you say, oh yeah, sure, that would be great. So that's an example. That's a way to help you outline and organize that information. So as I've mentioned the idea of retrieval cues a couple times already. A retrieval cue is simply a clue or a prompt that helps stimulate recall or retrieval of a stored piece of information from long-term memory. So, when we use the acronym HOLMES to remember the names of the Great Lakes, each letter in HOLMES is a retrieval cue. Now, when we are attempting to demonstrate our memory of information through recognition, this is one type of testing long-term memory, essentially, is through recognition testing, like a multiple choice test, for instance. You're retrieving a memory using a specific cue, a multiple choice test. So you're presented with a question and then 4 options, and one of them should look familiar as being the correct answer. The other 3 will not be familiar. That is, you did not learn that the answer to the question was A, C, or D. You recall, you recognize that B is the answer choice that is most associated with the answer to the question that's being asked. Recall, on the other hand, involves retrieving a memory using a general non-specific clue. So, for instance, if you were taking an essay test and you were just asked to talk about what is the difference between episodic and semantic memory. Another phenomenon that serves as a factor involved in our ability to retrieve information is called the encoding specificity principle. This is when we are able to retrieve information better when conditions of recovery are similar to the conditions when the information was encoded. So, for example, if you are drinking coffee while you're listening to this lecture or reading your textbook, you're in a somewhat altered state of mind because caffeine is a stimulant, or at least if it's caffeinated coffee. And so your ability to retrieve that information, to remember it later on, will be better when you're also drinking coffee. And this is something known as a state-dependent retrieval. That is, the mild arousal that you experience, the mild from the stimulant caffeine, actually serves as a retrieval cue when you're attempting to recall some information. It's a retrieval cue because it became associated with learning a particular bit of information at the time that you were studying it. So now we're going to talk a little bit about some aspects of forgetting. Okay, memory is certainly not infallible. Okay, it's subject to a number of mistakes, and it's also subject to just outright forgetting. So Nietzsche's famous for saying the existence of forgetting has never been proved. We only know that some things do not come to our mind when we want them to. So that might suggest that we never actually forget information. That we just may not be able to retrieve that information at the time that we're attempting to. Okay, most students have had this experience when taking an exam, and they say, "Oh, I just blanked. I couldn't think of that information, even though I really knew it very well." Or alternatively, you see somebody and you learned their name, and you have this strong feeling that you know their name, but you just cannot think of it at the time, and maybe it only comes to you later on that day. But that's sort of one of the interesting things about forgetting. So there are a number of different theories about how do we forget information. Well, the first theory suggests that, called decay theory, suggests that memory just deteriorates over time. That is, most things, like your car, for instance, over time, it just gets degraded from use. And so information is no different. It becomes degraded over time. When it gets degraded to the point where it's no longer recognizable as that same memory anymore, that's when we could essentially say that we've forgotten. And so that's one theory of why we forget information. Interference theory is when we forget information due to interference, and that interference could either be proactive or retroactive. Proactive referring to the fact that new information can interfere with our ability to attain present information can interfere with your ability to learn new information. So, for example, you're trying to learn someone's name, and they look like somebody that you know. Okay, you meet a woman named Sue, and she looks like a woman that you know called Jane, and you just cannot remember her name is Sue because when you first met her, you said, "Oh my goodness, this woman looks so much like Jane. It's incredible." On the other hand, you might have difficulty remembering previously learned information because you just learned some new information. That is, the new information interferes with your ability to remember things from the past, and so that's called a retroactive interference. But that's one general theory, interference theory, of why we forget. Another theory is that we are motivated to forget information. For instance, painful memories. Some have argued that when memories are particularly distressing, that there's some mechanism that we have that allows us to suppress that information. The encoding failure theory, of course, posits that the failure is in getting information from short-term memory into long-term memory simply because we didn't encode it properly. So you might meet a person and say, "Oh, hi, nice to meet you, Tom." You just said their name, and then 3 minutes later you're asking your friend, "Hey, what was that guy's name that we just met?" You had clearly initially processed that information. You had encoded it, but you didn't store it. Or I'm sorry, a better example even would be, if you just weren't paying full attention to what somebody had said to you, and that would be a better instance of an encoding failure rather than a storage failure. Finally, retrieval failure theory, we just talked about that a minute ago as well, is when information is or suggests that we forget things because the information is momentarily inaccessible. Okay, so as I said, there are two types of interference, proactive and retroactive. Retroactive is when new information interferes with old. Proactive is when old information interferes with new. Okay. So a number of factors have been studied in terms of how they can influence our forgetting. One effect is called the misinformation effect, which is when memory can be distorted, which resulting from misleading post-event information. So, for instance, there have been a number of studies where just the phrasing of the question can influence your recollection of an event that took place. Okay, so if you're provided with information that is false, that can essentially become part of your actual memory. Source amnesia is when you forget the true source of a memory. You think you told one person something, but you actually, or you think you heard information from one source, but you actually heard it from another source. Now that would be particularly problematic if you thought that you heard information from a reliable source, when in fact you actually heard it from an unreliable source, right? Because then you would think that the information is accurate, but in fact, yeah, because it came from an unreliable source, it's likely to be inaccurate. The sleeper effect refers to information from an unreliable source which was initially discounted, but then again later gains credibility because the source is forgotten. And information overload refers to just trying to learn too much at one time. That is, most students, once again, are very familiar with the method of cramming for exams. That is, not spacing out your studying adequately so that you end up spending the majority of your time spending all in one setting. And there's been a tremendous amount of psychological research to indicate that that is a far less effective memory for learning information in the long term. It actually, is not that much worse off in the short run. That is, cramming the night before an exam will allow you to remember that information to some degree the next day, but a week or two later, again in the long term, that information tends to get forgotten more easily. And so, a distributed practice, that is, spreading out your studying over the entire semester, has been shown to be much more beneficial in the long term than massed practice. Some other things that that psychologists have identified as being involved relate to the serial positional effect. This refers to the fact that information at the beginning is often information both at the beginning and at the end is often better remembered than information that is in the middle. So the fact that we tend to recall information from the beginning is called the primacy effect. The fact that we recall information from the end is called the recency effect. So think about this next time you go on your next job interview. That during that interview, the two things that are most likely to be remembered by the interviewer are your first impression, right? That's the primacy effect, and as you're leaving the interview, as you're wrapping things up, that's the recency effect. Okay, so keep that in mind. That's some psychological research that can be of benefit to you. Cultural factors, cultural practices even also influence how we remember information. That is, we tend to remember information that is consistent with our cultural beliefs. That is, again, memory is a constructive process. It's not just seeing things as they actually occurred, but it's reproducing information that is subject to sources that are currently present, such as cultural factors. Okay, now let's spend a few minutes talking about the biological bases of memory. One seminal finding that attempted to demonstrate what some of the molecular chemical bases of memory was research on long-term potentiation. So long-term potentiation, it just refers to a long-lasting increase in neural excitability. And this is believed to be at least one of the biological mechanisms responsible for learning and memory. There are two ways in which we can demonstrate long-term potentiation or induce it. One is with repeated stimulation of a synapse that can strengthen the synapse by causing dendrites to grow more spines. So you'll remember that the synapse is that little gap in between the connection between two neurons. Okay, so we're basically talking about two neurons being connected here. And by repeatedly stimulating them and getting them to communicate with one another, what can happen is, remember that dendrites are those branch-like extensions on the neuron that collect a lot of the information in the form of neurotransmitters most often. Well, they can actually grow these additional structures on the dendrites themselves, which are called spines. And that increases the surface area. It increases the ability of two neurons to communicate with one another. And also, it's the ability of a particular neuron to release or accept neurotransmitters, which can also be increased or decreased. That is, the number of receptor sites on a neuron can either increase, making it more likely to receive more messages, or it can be decreased. These are both experience dependent types of processes, the increasing and decreasing of the number of neurotransmitters. Hormonal changes can also have effects. So stress hormones, for instance, such as epinephrine and cortisol, although they can initially increase encoding and storage of new information, in the long term, it appears that long-term stress or even extreme stress can really interfere with memory. In fact, many research studies have suggested that long-term stress has an adverse effect on the hippocampus, such that there's atrophy of the hippocampal formation. That is, the size of the hippocampus actually decreases. On the other hand, emotional arousal is what permits us to have certain types of memories called flashbulb memories. These are very vivid images of circumstances, often associated with surprising or strongly emotional events. Due to the secretion of fight or flight hormones during the event and the repeating of the event in our minds, it becomes very vivid. Now, importantly, just because a memory is very vivid, as flashbulb memories might be, the classic example of a flashbulb memory, depending on what generation you're from, one of the more recent ones would be 9/11. Everybody seems to remember a lot of information about where they were and what they were doing on the day of September 11th, 2001. But just because it's very vivid and it seems very clear to you doesn't mean that it's any more accurate than non-flashbulb memories. I know that it's a little hard to believe because it feels like it's so clear, but again, one of the things that separates psychology as a science from our everyday experience with behavior is that when we conduct the research, so we ask people on September 11th, psychologists ask people to record everything that they remembered, and then they bring them back into the lab a year later, and they ask them to recall everything that they can remember from that day. And although everybody, as I just mentioned, usually feels like they can recall everything very well, there are still memory changes in the memory over time, and that only becomes apparent when you actually do that kind of research and track it. So there are a number of brain areas that are involved in memory. Initially, neuroscientists were looking for the brain bases of memory. They were expecting to find that memory would be located in just a single region of the brain, or that certain memories might be located in certain areas. And currently, that's not really the state of thought regarding memory. Memory now is believed to involve a number of different structures, which vary as a function of the type of memory. For example, the cerebellum, for instance, and the basal ganglia. These are involved in implicit memory more so than explicit memory, whereas the amygdala is more involved in memory for emotional experiences. The hippocampus and hippocampal formation, as well as the thalamus, are both important in terms of storage of declarative memories. And the cortex, in particular the prefrontal cortex, seems to be very important in encoding as well as retrieval of memories. So as I said, different brain regions are involved differentially in different aspects of memory as well as different types of memory. Okay, but you're not going to find any single memory in any single location in the brain. The current thinking is that these memories are represented in the connections between neurons rather than within neurons themselves. One of the other things that we can see in terms of memory disruption from brain injuries is that there are two distinct types of amnesia. Most people have heard of amnesia. It refers to just a general loss of memory, but there are two types. Okay, in retrograde amnesia, a person loses memories of events that occurred before the accident. It's very rare that anyone would have only retrograde amnesia and that is be able to remember everything that occurred after the accident but nothing before. That would be very rare, and it would actually be a little suspect if somebody were to report that that was the case, because anterograde amnesia is a much more common type. In fact, they're usually both present, but anterograde amnesia has a tendency to last a little bit longer, but the two are normally both present, at least to some extent. So in anterograde amnesia, older memories from before the accident tend to be okay, but you lose the ability to form new memories. So I mentioned when we talked about case studies, the case of HM, very famous study in psychology. He had he had some retrograde amnesia, but he had a much more severe anterograde amnesia because he was in his early 20s when he had that surgery that removed his hippocampus, and he became unable to form new explicit memories. Okay, in which case that would be anterograde amnesia. It wasn't an accident that caused it; it was a surgery, but nonetheless, it was an inability to form those new explicit memories after the cause of the damage. And then certainly Alzheimer's disease has also given us some indication of how memory functions work and get disrupted. Alzheimer's disease, of course, results in an extreme decrease in explicit and declarative memory. They do. Most people tend to retain some, and even most, I could say, implicit or non-declarative memory. But there are two characteristic findings that are involved in Alzheimer's disease. They're the pathological markers that are actually required for a diagnosis, at least to be confident in the fact that it is Alzheimer's and not another disease, is the presence of what are called beta amyloid plaques and neurofibrillary tangles. And these have to do with the buildup of certain proteins in the brain that block the ability of neurons to send messages, and disruption in a protein called tau within the axons that allows that message to get sent from one neuron to the next. And so this is actually just a PET image here, positron emission tomography scan, showing that there is a great deal of hypometabolism. That is, the brain is just not utilizing glucose the same way, suggesting that it's very underactive in certain areas in comparison to the normal brain. So the things that we've talked about here are very important in terms of the fact that we know that memory can be distorted. In terms of explaining, why do we shape, rearrange, and distort our memory so much? Well, some evidence seems to suggest that we have a need for logic and consistency, that we make corrections to our memories so that they make more sense to us. We're always on a quest to understand our world. We're always asking, why did this happen? Why did we do that? And so we're always looking for logic and consistency. We also shape and construct our memories for the sake of efficiency. We often summarize, augment, and tie new information in with related memories in long-term memory. There's no reason to remember every single detail of what we've eaten for lunch, every single day of our lives. But it would be efficient to know, in general, what do we tend to eat. Okay, it's not important to know what did we eat on, March 28th, 2011. It would be more important to know that, in general, for lunch we like to eat turkey sandwiches. Okay, so it is actually an adaptive function that we don't recall every single event from our lives. And of course, this has significant implications for our criminal justice system because usually in courts of law, eyewitness testimony is given a high value in terms of um, constituting evidence for innocence or guilt. However, most jurors do not understand how unreliable eyewitness testimony actually is. Confidence in memory, as I said before, when I was talking about flashbulb memories, is not a good predictor of accuracy. False memories can be implanted in people. Nobody is immune to having people make suggestions to you, and then you beginning to believe that you had an experience that you actually did, and this has actually resulted in a very bitter debate about the idea that people can actually repress memories. Repression being the supposed unconscious coping mechanism by which we prevent anxiety-provoking thoughts from reaching our consciousness. Again, some people would argue that there is no such mechanism, such as repression, or alternatively that there's no means by which undoing that repression. Those researchers would often argue that if you do believe that you've uncovered a repressed memory, you've more likely to have implanted a false memory. But as I said, there's a bit of a bitter debate going on in terms of the people that believe that they've uncovered these things. It's a little difficult to believe that something that I believe I have uncovered in myself is actually not true. So they can make a pretty convincing argument, but the research is more on the side that memories do not get repressed, and even if they do, that it's unlikely that they can be recovered in any special way, such as through hypnosis or anything like that.